Okay, let's go through a couple of examples how we can use this G by E by M framework to analyze how cropping systems change, how they improve. The first example is a well-known one. It's the Green Revolution. You've probably already heard about this, but let me give you the Coles notes. Okay, so in the 1960s and 1970s, many eminent scientists were predicting mass starvation in the near future. Right? It was basic arithmetic. The rate of population growth was faster than the rate of agricultural productivity growth. In other words, the population was increasing faster than food supply was increasing. And so eventually we were going to run out of food, resulting in mass starvation at a global level. And there's a famous book by a famous scientist called The Population Bomb. Of course, this turned out not to be true. Okay? There was not global starvation in the 60s, 70s, or any time since. And in fact, the rate of food production started increasing dramatically. And the reason for this increase in food production in the 60s and 70s, especially in the developing world, is called the Green Revolution. And it's the adoption by small-scale farmers, relatively poor farmers across the developing world, of new types of varieties of rice and wheat and new management practices. So the Green Revolution, that's the Green Revolution in a nutshell. It involved millions of farmers around the world. It involved thousands of scientists as well. But if there's one person who can be the figurehead of this Green Revolution, it is Norman Borlaug. Norman was an American wheat breeder. He developed several improved varieties. He worked primarily in Mexico, but also other parts of the developing world. And if we can ask one person, if there's one person responsible for the Green Revolution, we would say it's him, because he introduced new management practices and new varieties. Of course, in reality, it was not just him, it was many people working together. Shorter varieties of wheat and rice have two distinct advantages over taller varieties of these crops. The first is that they're much less susceptible to lodging, and lodging is a phenomenon where the crop, instead of standing up straight like we want it to, falls on its side. It falls flat on the ground. Essentially, the crop grew too tall and then a gust of wind blew it over, and it stays on the ground. It's much more difficult to harvest when it's lodged, and yields are reduced, sometimes up to 30% yield reduction in a wheat or rice crop that lodges. So lodging is bad, and shorter varieties are less susceptible to lodging. Number two, shorter varieties of wheat and rice can accept higher amounts of nitrogen fertilizer, and they can take that nitrogen fertilizer, and instead of using it to get taller, instead of just growing taller, they will use that nitrogen fertilizer to increase their grain yields. Okay, so in terms of responsiveness to nitrogen fertilizer, shorter varieties are much more responsive. They're going to have much higher yields compared to taller varieties when nitrogen fertilizer is applied. They just use that nitrogen more efficiently. They convert it into grain yield. So in summary, these newer varieties of wheat and rice had two clear advantages. One, they were shorter. Number two, they could use nitrogen more efficiently. And these two traits synergized spectacularly with nitrogen fertilizer, because applying nitrogen fertilizer typically increases the risk of lodging for cereals, right? Those crops are going to grow taller in response to nitrogen. Taller crops more susceptible to lodging. But if you could apply more nitrogen to a cereal crop, and that wouldn't get taller because it's a modern variety, and it would use that nitrogen more efficiently to build yield, well, then all of a sudden, a farmer can grow these new varieties and increase the productivity way more by applying nitrogen fertilizer. In the developing world, farmers are much poorer than they are in a place like North America. Okay, they don't have access to capital. They're often food insecure. Okay, and so telling a farmer, hey, grow these new varieties and invest your limited amount of money into this bag of fertilizer, which is, very expensive relative to the type of income these farmers make. that's a big risk that these farmers are taking to invest that money, their limited amount of cash into fertilizer. So convincing them to do that, to grow modern varieties, apply a higher nitrogen rates of fertilizer than they were used to, that was a recipe for massive success. But it was hard you had to convince farmers to do it and take that risk. So the Green Revolution was due to the interaction between improved G and improved M, not just one of these factors alone. And this is a graph that you see that perfectly explains this interaction with some real data from, the Green Revolution. Okay, so on the x-axis, we have nitrogen fertilizer rate from 0 to 200 kilograms of nitrogen per hectare. And on the y-axis, we have grain yield. And this is of different wheat varieties. We have 3 wheat varieties. I'll only focus on 2 here. We have the older wheat variety, pre-Green Revolution, in a triangle. And then we have the newer dwarf wheat varieties in the square. And so this kind of graph we call a yield response graph, because it's showing the responsive yield to different rates of nitrogen fertilizer. So if only M changed, in other words, if only the nitrogen fertilizer rate that a farmer applied changed, that management factor, but that farmer kept the G the same, kept the same old tall variety of wheat, then they would have increased their grain yield by about 2 tons a hectare, going from roughly 2 to 4 tons per hectare, just if they changed their nitrogen fertilizer rate and stayed with that older wheat variety. So if a farmer kept their M or management the same, right, they applied a very low rate of nitrogen fertilizer, let's just say 0 or 40 kilograms of N per hectare, and all they did was change that G component. They just grew the newer varieties of wheat. And then they would have increased their yields by about 0.5 to 1.5 tons per hectare. Okay, so just by modifying the G, they would have wheat yields approaching 5 tons per hectare. So here we can see the effect of yield when a farmer both increases his or her nitrogen fertilizer application rate and grows those newer varieties, those short stature varieties of wheat. Okay, we have a multiplicative increase in grain yield. Okay, it's more than the sum of its parts. If we just, if a farmer just grows those new varieties of wheat, then they can increase their yield by about 0.5 ton. If they just increase their nitrogen fertilizer rate, growing those same older varieties, they can increase their yields by about 2 tons per hectare. But by doing both at the same time, we have a much larger increase in grain yield, effectively doubling what was previously achieved. I want to talk now about G by E interactions, focusing on how the environment is changing over time. So the climate is warming, and northern locations are warming as well. Okay, so in northern Ontario, this is a graph from a very official report. We can see that annual average GDDS, or growing degree days accumulation, is increasing. Okay, so the growing season is getting longer and it's getting warmer in northern Ontario. And what that means is that farmers in these regions can take advantage, if they so choose, and plant crop varieties that previously could not be grown because the growing season wasn't long enough or warm enough. And indeed, if we look at the data, that is what northern Ontario farmers are doing. They're growing more crops that previously could not be grown in the area. Okay, specifically looking at corn and soybean, grain corn and soybean acres in northern Ontario doubled or more between 2006 and 2011, and then between 2011 and 2016, for example, soybean acres doubled again. Okay, so there's still not a huge amount of acreage of these crops in northern Ontario, but the growth in the acreage of these crops, massive growth, is due to changing environment, a warmer environment, and also improved genetics. These are short season grain corn and soybean varieties that can mature in a relatively short period of time and therefore can reach maturity given the growing season in northern Ontario. And so we have a G by E interaction that is driving this change in Northern Ontario cropping systems towards corn and soybean.